In this video, we're going to talk about making payments on a car loan. So the example says this: while in graduate school, Dr. Fulkerson took out a loan to buy a used car. It was a 3-year loan for $5,000 at 6% compounded monthly. What were his monthly payments? By the way, this is a true story. I actually did take out a car loan for $5,000. I think the car itself cost maybe a little more than $7,000, but I had a little over $2,000 in the bank that I paid toward it. But I went to a bank, went to a credit union actually, and took out a loan for $5,000. And I think it was about 6%. That's the one thing I'm not so sure about. But it was for 3 years. Okay, so the question is, what were my payments? How much did I have to pay each month? Okay, now another way to sort of ask the same question that my math lab has is find the payment made by the ordinary annuity with the given present value. Okay, so really what I was doing is I was paying on an annuity, right? I was making the same payment each month, right? Every month. And so it says find the payment made by the ordinary annuity with the given present value. Notice the present value is $5,000. That's what the loan was worth right at the beginning, right? $5,000. So that's the present value. And I made monthly payments for 3 years, and the interest rate is 6% compounded monthly. Okay, now we're going to round our answer to the nearest cent. Okay, but really this is two different ways of asking the same question. Okay, so how do we do this? Well, I want you to recall the formula that we have for the present value of an annuity. Now remember, P is the present value, R is the payment. Okay, so here we know the present value. The present value is $5,000. The question is, what is the R? Okay, how can we find the payment? Okay, well, one way to do this is just plug in all the numbers, plug in the I and the N into this formula and the P, and then so you'll have everything in there except for R, and you can find R once you know what this is and what this is. But another way to do it is really just take this formula and rewrite this formula, do some algebra on this formula, and solve it for R. Okay, so R is going to be P divided by this fraction. Or another way of saying P divided by this fraction is P times the reciprocal of this fraction. Okay, so when you do that, you get this formula. You can check my algebra if you want to, but this is the formula that you get for the payments on this car loan. So R is the payments. And in fact, here is the more sort of technical statement of this formula. It's talking about amortization payments. So when you're paying off a car loan or you're paying off a mortgage, you're amortizing the loan. Okay, a loan of P dollars at an interest rate I per period may be amortized in N equal periodic payments of R dollars made at the end of each period, where R is given by this formula. Okay, so remember, P is kind of like the present value, or in other words, it's the initial loan amount. So P can be thought of as either the present value, okay, or the initial loan amount. Okay, it's the same thing. Now the R is the payments. Okay, so let's do this for the specific example that I had. The P that we had was $5,000. Okay, that's the loan that I took out. The I was 6% interest, now so 0.06, but remember it was paying each month, so you have to divide by 12. If you do this, you get 0.005 if you type that in a calculator. And the N, well, I was paying it for 3 years, once a month for 3 years, so 3 times 12 is going to be 36. Okay, so I made 36 payments, equal payments. My I was 6% divided by 12, 0.06 over 12, which is this, and my P is 5,000. So what is R? Well, we just need to plug this into our formula here. R is equal to PI, so 5,000 times, it'd be 0.005, divided by 1 minus, now 1 plus I is going to be 1.005, okay, to the negative n, so to the negative 36th power. Now if you type this into a calculator, let's, I would type it like this. You could put the whole numerator in parentheses if you want to. You don't have to because we're not adding or subtracting, we're multiplying. So you can put 5,000 times 0.005 and then divided by, now I would put the whole denominator in parentheses because we don't want to just divide by the 1, we want to divide by this whole thing. Okay, so what we get is 1 minus, okay, 1.005 to the negative 36th power. And I guess you could put this in parentheses if you want to. Okay, so that's how you would type it into your calculator, just like this. Okay, and when you do this, you get this amount. $152 and well, it's 0.1096. Well, rounding to the nearest penny, it'd be $152.11. And if I remember correctly, I think my payment was just about that amount. In fact, I think it was about $149. But I think the interest rate might have been slightly lower than 6%. Lower than 6%. All right, $152.11, rounding to the nearest penny. Okay, in future videos, we're going to talk about paying off a mortgage, and really the formula is going to be the exact same here. We have really the present value formula, but instead of being solved for P, the present value, the formula is solved for R, the payments. Okay, so we're going to use this formula on all of those problems.